Okay, Tom, so to try and make this video a bit shorter, because it's so massive, megabytes, I've just drawn the diagram up here and done a bit of the work into sort of insert, what's going on here. So we know that in equilibrium position, this is 1.2 metres, so this has to be 0.8 metres. And in simple harmonic motion, you have to know where your equilibrium position is, and we know from the first part that equilibrium is here. So what we're going to do is to show simple harmonic motion, but we've got to have it in terms of x. So we put in our x is measured in that direction from my equilibrium position, but now of course what the change is that the tensions are changing. So now there's a resultant force, which will be TB minus TA, and that's equal to m times my acceleration, which is x double dot. So TB, using Hooke's law, 18 over 1.5. My extension I need to be careful about, we'll talk about that now in a second, minus TA is equal to 0.5 x double dot. So thinking about these extensions, TB, that distance there is 0.8. So as this moves out, the extension will be 0.8 minus x. This one, extension, is going to be 1.2 plus x. If you can, if you're happy with that. So we would have 0.8 here, and then we would have 1.2 there. So we have got 12 times 0.8, obviously, is 9.6. 8 times 1.2 is 9.6. So these two portions cancel out. So we end up with minus 12x minus 8x is equal to 0.5x double dot. So we would have minus 20x is equal to 0.5. So we would have then my acceleration x double dot is equal to minus 40x. So this shows that we have got simple harmonic motion where omega squared is equal to 40. Once you've got that, you can then use all of the simple harmonic motion formulae to work out everything else. Now the impulse of 6 Newton seconds comes in at the next stage effectively. Because it's in equilibrium at rest, my impulse, which is given by the change of momentum, obviously is going to give us what the speed is at my equilibrium position, and the speed at equilibrium effectively is Vmax. So you use your formula for Vmax to work out A, and then you can just use your normal equations. So hopefully that should get you through that question. So here we'd have 0.5 times by V, because U is 0. So V max would equal 12 meters per second. Okay, I'll hopefully that'll explain something. If it doesn't, then it's easier to do it live, because then you can ask me questions. But anyway, I'll see you tomorrow, hopefully anyway. All right then, take care now.